Hi everyone, today we are going to start paper 6 of IGCSE Physics, variant 1. It's the October-November 2024 paper. Let's begin with question 1. What they're asking in first question, a student investigate the period of a pendulum, and this is the setup they have shown. The floor, there is a bench on which there is a pendulum is placed, and this is the support that they have labeled. The length of the pendulum is d, and the distance from the floor till the support is x, right? So what they're asking in part A, a student adjusts the length of the pendulum until the distance d made from the bottom of the support to the center of the bob is 90 centimeter. Okay, so this will be 90 centimeter. Then he displaces the bob slightly and releases it so that it swings. He measure and record table 1.1 the time period for 10 complete oscillations. What we have to calculate the period t of the pendulum. The period is the time for the one complete oscillation. They have defined what the period is as well, right? So period is for the one oscillation. What they have calculated is for the 10 oscillations, right? So how you can calculate t? T will be total time divided by number of oscillation. Number of oscillations are 10. So for this thing you have to, this value will be used, it's 19.1 divided by 10. So you will get 1.91 here, right? And then you have to find t square. So you just have to take the, this is 1.91 for t square, 1.91 whole square, that will give you 3.65. Okay. In B part, the student repeats the procedure using a distance of 45 centimeter. Calculate and record in table 1.1 the period t of the pendulum. Calculate the value of t square, and okay, so you have to fill it for this thing as well. So same process, this for this thing, time period is t divided by 10. Now t is 13.5 divided by 10, so that will give you 1.35. So 1.35 you will write here, right? And then you have to find t square. For t square you will be 1.35 whole square, that will give you 1.8225, so you can write 1.82. okay, so let's move to the part C. In part C they're asking complete the column headings in table 1.1. okay, so first heading is for the D, it's already completed. The time is made in seconds, time period will also be in seconds, and when you take the square of the time it will be second square. Okay, so we are done with the C part as well. In the D part, explain why timing 10 oscillations gives a more accurate result for the period t than timing one oscillation. Okay, in time experiment, what the error is most important that we have to minimize, that is the human reaction time, right? So we take more oscillations or a longer event. Why? To reduce the time, human reaction time error, right? So what we will write, human reaction time error will be less significant, or you can write down it will be reduced. Okay, when you use more oscillations, right? Okay, for part E, describe one technique that you use to improve accuracy when measuring the distance d. You may draw a diagram to help your description. Okay, so what we are measuring, distance, what was distance d? This is the distance d, right? So what we can do, there are two different choices we have. To measure this distance, we can use set square, right? So set squares can be used to measure this distance, or what we can do, we can place scale close to this thing so it can accurately measure the distance, right? If the scale is placed at this point, we can't measure it accurately unless we use the set squares. Okay, so here we can use set square can be used to take reading. Okay, or you can say this, you can write down, or you have to write down only one of them, right? So you can use meter rule. Meter rule can be placed okay, so this can be the second answer. You have to write only one of them because it's a 1 mark question, right? Then they are describe one technique that you use to improve accuracy when measuring the time t for the 10 oscillations. Okay, so they're already told you for the 10 oscillations, so you can't tell them that we are taking more number of oscillations or we are taking less number of oscillations, okay, because that is fixed. So what we can do, let's suppose if this is the pendulum, you can set some reference point from which you will start the stops, right? It's going to move at this point, then it's going to move at this point, right? So you can use a clearly visible or a point from where you can start counting. It can be this point, it can be this point. Okay, so you can say this, use fiducial point to start counting. Okay, what you will do, you will move the pendulum. When it crossed this point, let's suppose, then you will start your counting. So from there you will start the 0. So when it again cross this point, then you will count 1 2 3, or you can take this point as well. Okay, this point is more feasible because when that thing reached this point, then one oscillations will be completed. Okay, but for if you are taking this middle point, then you have to be careful, because if it is starting from this point, it will go there and then come back. This is not the one complete oscillation, right? You have to wait, then it will come back here, then one oscillations will be completed. So it's always better to take this point or this point from where you are starting the from where you are counting, right? So whenever it reach at this point, you will count 1 2 3 4 like this. Okay, then in question G, the pendulum support is 40 centimeter above the bench. Estimate the distance x between the bottom of the pendulum support and the floor. Okay, so pendulum support is 40 centimeter above the bench. So this is 40. This thing was 90, it was given here. So you have to tell this thing x. So 40 plus 90, it will be 130 centimeter. Okay, approximately, because we are changing this length, right? So it will be 130 centimeter, you can write. In part H, a student plans to plot a graph of t square against d. Suggest suitable values of d that the student can use to obtain measurements that are sufficient for this task. Achha, what we are doing, we are changing the length of the pendulum, right? So you can use different values. What they have given the value that was 90 centimeter. So what we can do, we can take value of 50 centimeter, right? Okay, you can write down 60 70. Just make sure that value should be smaller than this value x. Why? Because if it is greater than this x, then the pendulum is going to touch the floor. Okay, so that will not give you the accurate value. So any value less than this value, it's acceptable. And suggest suitable number of D. How many values we can take? We can take 5 values can be taken. Okay, you can write on 5, 6, 7, but that should be at least 3. Okay, values that are taken for repeating the experiment, they should be more than 3, at least 3. Okay. Okay, let's move to the question 2. A student investigate the cooling of water in a metal container. The student uses a thermometer to measure the room temperature. Room temperature is shown 23 degree. You have to show on the thermometer that where the 20, show clearly on figure the theta r. Okay, theta r is 23. So it will be, this is 20, 21, 22 and 23, right? So here you can show this is, or you can label it as theta r. Okay, 23 degrees Celsius. Then in part B, a student pours 200 centimeter cube of water into the metal container. She places the thermometer in the hot water in the container. She records the temperature at time 0 and immediately start a stopwatch. She records the temperature in table 2.1 after 30 centimeter intervals. Okay, we have to complete the headings in the table 2.1. Okay, so this is time, so time is made in seconds. Okay, that is given as well, and this is the temperature, so it is made in degrees Celsius. Okay, okay, let's move forward. What you have to do, plot a graph of temperature theta on the y-axis against time on x-axis. Label your axis appropriately. You do not need to start the y-axis from 0. Draw the best fit curve. Okay, okay, so first thing, the labeling of the axis. So y-axis is theta, theta slash degrees Celsius, and for x-axis it is the time slash second. Okay, this is for the 1 mark. Correct labeling will give you the 1 marks, right? The second step is scaling. Okay, so if you are going to scale x-axis, x-axis is starting from 0 and ending at 3. So you have value from 0 to 3. And how many boxes we have? 1, 2, 3, 4, 5, 6. So I guess this can be 0 0.5, it can be 1, it can be 1.5, it can be 2.0, 2.5 and 3. Okay, at least you have to scale it in a way that at least 3/4 of the area of the graph will be utilized. Okay, then it will be considered as correct scaling. Okay, now we have to scale the y-axis. Y-axis least value is 74 and maximum value is 92. So what range we have? We have maximum 92, minimum 74, that is 18. And how many boxes we have? 1, 2, 3, 4, 5, 6, 6. So 18 divided by 6 is 3. So it can be labeled as it. We don't have to start it from 0, right? So I'm pointing this point as, so for x-axis it is 0, and for y-axis this point will be 74. Then I will take the interval of 3. Okay, 74 plus 3 is 77. Then it's 80. 80 plus 3 is 83. 83 plus 3 is 86, 89 and 92. So here we have a complete range of the values. Okay, so now let's point out the coordinates what we have. So these are the coordinates that we have to plot. Okay, so first coordinate is 0 and 92. X is 0 at this point, so you can draw a line, and this is the 92. So this will be the point. Okay, so this is the first coordinates. Okay, second we have 0 0.5 and 86. This is 0 0.5 and this is 86, so this will be the point. Okay, so this is the second coordinate. Third we have 1 and 82. This is 1. Okay, where is 82? So, but each point, as the big box is equals to from this to this is 3. So each small box is representing 3 by 10, that is 0 0.3, right? So I have to look for the 82. So between this is 80, it's 80.3, 80.6, 80.9, 80.12, 80.15, 80.18, and 82 point, sorry, 1. Okay, so this will be the 82 somewhere. 82, and second coordinate is 1. So 1, it will be somewhere at this point. Okay, at this point. Fourth coordinate is 1.5 and 79. So 79, this is 80. So you have to go more than 3 boxes down. 1, 2, 3, and more. Okay, so 1.5 is at this point, and it's 79. This is 80. 1, 2, 3, and a bit lower. So this will be the point for the next coordinate is 2 and 77. This is 2 and this point is 77, so it's easy. And 2.5 and 75. 2.5 is there, and 75, this is 74. So more than almost 3 lines, boxes 1, 2, 3, and somewhere at this point. Okay, so 1, 2, 3 at this point, and then 3 and 74, it will be there. Okay, so these are the points we have. So it's clearly visible that it will be it's a curved. When you plot a best fit line, you have to draw a smooth sharp line passing through all these points. Okay, so this is the curve that you will get. Okay, so for the best fit line you will get 1 mark. 1 mark is for the correct labeling, 1 is for the correct scaling, 1 is for the correct coordinates, and the last mark is for the best fit line, smooth, sharp, curved. In D part, a student states that the average rate of cooling of the water decreases as the temperature of the water approach room temperature. State whether your graph lines support this suggestion. Explain your answer by reference to the shape of the graph that you are getting, that you just have plotted, right? You have to tell the reference of that thing. Okay, if we see the graph, that thing is supporting that argument, right? So it's yes. Why? Because gradient of line is decreasing with time. Okay, that supports the statement. And for E, explain why it is good practice to read the thermometer scale right angle to the reading. So this is to avoid parallax error, right? Parallax error. And for part F, draw a measuring cylinder containing water on your diagram. Show the line of sight you see to obtain. Okay, so what we have to do, we have to draw a measuring cylinder. Okay, then you have to draw water in it. So let's suppose this is the water level, the meniscus part, right? So this is the water, and from where the eye will be should be at, you will take the reading from bottom of the meniscus, so the eye will be at level with this thing. Okay, this is how you can draw this diagram. Okay, let's move to the part question 3. In question 3, a student investigates the image produced by a lens, shows the setup as shown in the diagram. This is the convex lens, there is the object, this is the screen, and these all things are placed on the bench. And this is the height of the object. What they're asking, measure the height of the object. So you have to use the scale to measure it. Okay, place the scale like it should be perpendicular, right? And place the 0 at one end and then take the values. It's 1.6. Okay, so it's 1.6 centimeter. Okay, and second, what we have to do, they are asking about describe two technique that you use to obtain a clearly focused image. Okay, in light experiment, how you can increase the focus, you can slowly move screen back and forth. That can clear the image. Or you can do the experiment in dark room. Okay, to perform the experiment, right? Okay, in part C, calculate the focal length f of the lens using the equation this. Okay, you just have to put the values, and values are given above. This is the value of v, and this is the value of u. Okay, that is given in the b part. So here you just have to put the values. For u it is 25, for v it is 41.2. so 25 plus 41.2, that thing will give you 1030. 66.2, that will be 15.558. Okay, so you can round it off and write it as 15.6 centimeter in 3 significant figures, right? Okay, in part D, the object is brighter than the image. Complete the sentence to describe two other ways in which the image seen on the screen is different from the object. Okay, let's see. This is the object and the image is formed by the convex lens. Okay, and the object is placed very close to the lens and the image is at a greater distance as compared to the lens, right? So as we know, the image is formed by this lens, it's projected on the screen, so the image will be real, right? So real image is always inverted. So one feature is this, the image will be inverted. Okay, second, as object is placed close to the lens, so the image will be magnified. Okay, then you have to calculate the focal length again with the different values. Now the v is this and u is this given. Okay, just you have to put the values. It's 30 into 29.8 divided by 30 plus 29.8, that will give you 894, 59.8. So answer will be 14.9498. You can write as 14.9, okay, for the three significant figures. In part F, state and explain whether your result for the focal length f are equal within the limit of accuracy or not. Okay, we have two values, 14.9 and one values is 15.6. So they are in limit of experimental accuracy with each other or not. How we can check? The limit of experimental accuracy is plus minus 10%, right? So they are in that range. How? F is one F was 15.6, and when you do plus minus 10%, so what it will be? Range will be from plus minus 10% means the 10% of 15.6 will be equals to 1.56, right? So when you plus this thing and minus this thing, the range will be 14.04 to 17.16. Okay, and for the second F, the value is 14.95 plus minus 10%. So range is 13.45. We will subtract and add the 10% of 14.95 in that value. Okay, so that will give you 16.445. So if you see, this is from 14 to 17 something, and this is from 13 to 16. So they are overlapping with each other, few of the region, right? So you can say range is overlapping. Okay, so that is the reason why they are in the range of experimental accuracy. Let's move to the question 4, that is the planning question. And a student investigate the current required to melt different fuse wires, shows a part of the circuit the student uses. The following equipment is also available: fuse wire with selection of different diameters and metals, and all are of the same length. Okay, so whatever the information is given in the question, that cannot be used in the answer. Okay, so as they are telling you all the materials are of the same length, so you can't take this thing as the fixed variable, okay, because that is already fixed. You don't have choice for that thing. So meter rule, ammeter, variable resistor, you have plan experiment to investigate how one factor affects the current required to melt a fuse. You do not need to write about safety precautions. Okay, so what we can think about, how we can do this experiment. One way is I can use, the length is same, but I can change the thickness. I can take more thicker wire, then I can increase the thickness of wire again the same, and I will check how much current can melt this thing, right? One way is this. So when you are doing this, when you are changing the thickness, what you have to keep constant, the material that we are taking, the metal, let's suppose you're taking the copper or the iron, you will use the same material, right? One is that way. Second, what we can do, we will take different materials, right? One time I will add copper here, one time I will add iron, but what I will keep constant, then I will keep the diameter constant. Okay, so it's your choice how you're doing. So let's do it with the diameter. Okay, so state the variable that you choose to investigate. What I'm going to investigate, okay, this part is for the 1 mark. Okay, so first we have to give the heading, that will be the independent variable. Independent variable is the one that you will change. Okay, so independent variable is diameter, you can say d of the wire, that I will choose independently. Okay, so for this you will get 1 mark. The next, complete the circuit diagram. Okay, So let's move to the circuit. What I have to do, I have to check the effect of current, right? So I have to measure that thing. So to measure current, what I need ammeter. I can install that ammeter in, ammeter is always installed in series, okay? And then I will change the amount of current until that wire will melt, right? So how I can change the current? Current can be changed with the help of variable resistor, okay? So this is a sign for variable resistor. Variable resistor, okay? So you will get mark for this thing. Complete the circuit diagram. Then explain briefly how to do the investigation. Now this thing can give you maximum 2 marks, okay? So this is the procedure that we have to follow, okay? So what we can do, take wires of different diameters, measure diameter with help of micrometer, screw gauge. Then what we will do, now we will connect one fuse wire and turn on the power supply, okay? So now the power supply is on, the wire is installed. What you have to do, you have to change the current, right, until the fuse will melt, and you will note the value from the ammeter. Now I will increase current, increase the value of current with help of variable resistor. Until fuse wire will melt, okay? Now what we will do, we will record the value, of current from ammeter. Now we have to repeat this experiment with wires of different diameters, okay? So this is, we are done with the procedure. Now what's the next? State the key variable that you will keep constant, that is for the 1 mark. What we are keeping the constant, so the heading will be constant variable. Constant variables are, we are using same type of metal, okay? The length of the wire you can't write because it is already given the question that the length is same, and you can't even write the temperature because temperature is not constant. If the temperature is constant, the wire is not going to melt, right? When you are increasing the current, the temperature will increase, so that is how the wire will melt. So you can't write the temperature in the constant variable, it will be taken as wrong. And next thing is, you have to draw the table with the column headings to display, and you're not required to write down the readings, okay? In any question you don't have to write down the readings. So for the table we have one independent variable and one is the dependent variable. So we have measured the diameter, it will be in millimeters, and we have taken the values of current, that will be in ampere. Okay, that's it. You just have to write down the headings with the correct units. Okay, and that's it. You don't have to fill this table, and you will get 1 mark for this thing. And the last point, explain how to use your result to reach the conclusion. Okay, so for the this will be, okay, plot a graph of current against diameter of wire to compare the changes or the values, right? That is for the last 1 mark. So that is how you can get full marks in this question. Okay, so that's it. We're done with this paper. See you in the next video. Take care.